Good afternoon and welcome everyone. It's amazing to see that so many of you have joined us for this special occasion, the review of our car. I am Artje, the team manager.
And I'm Ramon, the technical manager. Today we will take you through the process of the making of our car.
But before we take a look at our team's journey, we want to take a look at the journey of the teams before us. It's because of their hard work that HyDriven could become what it is today. We learned from them and built further on their innovations. They created the foundation for our year.
Building a Formula Student car on hydrogen is not an easy task. Last year, after 3 years of innovation, Nebula was the first car ever within Formula Student to drive all the dynamic events on hydrogen. An amazing achievement, and we want to engineer a car to top that.
But before we go into the technical details about our car, let's reflect a bit more on our team. Around June last year, we all got the call that we would be the next HyDriven. And I think I speak for everyone if I say that this was very exciting news, and we could not wait to get started.
Agreed, especially when we're surprised with a new name and identity.
True. I think blue is more my color anyways. And then, while the previous team was busy writing history in France, our team was starting to get a bit nervous, but mostly very excited for the start of our year. We were ready for a challenge, ready to make an impact. Now, it was our turn. We were ready to prove the potential of hydrogen and accelerate towards zero emissions. Everyone in our team had big ambitions, so we set our goals and got to work.
We decided that we wanted our car to be competitive, reliable, and powerful. We set the goal to double our top speed and triple the hydrogen capacity. Also, by having a driving car at the beginning of the year, we could start off strong by gathering test data, which could immediately be implemented into our designs. But before we could start the design phase, we had to learn how to design a car.
And, may I add, before learning how to design a car, we had to get to know our team. So we started off strong. The first 2 weeks, we did not spend a single day apart. We went from our regular work week into our team weekend and into another work week. If that doesn't break the ice, I don't know what will.
Of course, Maartje, you think about the people in our team. But the team's main goal is to build an awesome racing car. To achieve that, we started by learning as much as possible, as quickly as possible. Following workshops, meeting with experts, and learning from the old team has helped us become experts in our own fields. And the more we learned, the more passionate everyone became about the part they would be designing.
And that is exactly where we crossed our first hurdles, because with all that excitement, people sometimes forgot that we were building one car, not 32 different cars. All sub-teams had to learn how to work together so we could achieve the common goal of building the best car possible. However, arranging good communication between 32 people, all from different backgrounds and representing different sub-teams, it takes some time and practice.
And that was not the only challenge. As a team, we had big aspirations. We wanted to make many improvements, but we had limited time and resources. So we learned how to prioritize and make tough decisions. Next to that, we went through lots of testing before the races, which meant even stricter deadlines for the designs. And we quickly learned that 1 year is quite short, especially when, for whatever reason, things do not go according to plan.
Yep, that can feel like quite a setback sometimes. But I also think it's one of the most important things we learned as a team. We learned how to adapt ourselves, to be creative, and to find a way to fix the problem. We are now only 9 months into our year, but it already feels like we have years' worth of experience. Every single member of our team went through immense personal and professional growth. And I am now confident to say that we've all become experts in our fields, whether that field is marketing, engineering, or management.
And we did not only develop ourselves within our own fields. We also went outside of our comfort zone many times. For example, we have never given a presentation to more than 500 people. Luckily, we got experienced at representing the team at all the events we go to. Showing our project to the rest of the world is a very important part of our mission, so we went to some pretty cool events, such as the Hannover Messe, the Nationale Autobeurs, or Tech Beach.
And we did not only inspire the general public, we also connected with the younger generations. We visited elementary schools, gave tours around our workshop, and it was amazing to see how even the younger generations are inspired by what we do. The excitement they and all the other people we talk with about our project have, it's amazing. And that excitement is something we get to take with us. It motivates us to work even harder.
Agreed. Seeing the excitement is great. Also, our competition, Formula Student, is inspired about what hydrogen can do. Together with them, we aim for a sustainable future. So together, we created an official hydrogen rulebook to set up the first hydrogen class in competitions throughout all of Europe. And by seeing what we can do, other teams are inspired as well. This results in future competitors, with the first competitor already joining this year. And so, after years of fighting, we finally made it happen. This year, for the first time ever, we will be competing in a hydrogen class in Formula Student.
And talking about our competition, Formula Student, the races are the moment where we can show the world what hydrogen can do and inspire other student teams to also start innovating with hydrogen. So this year we decided to take it to the next level by not going to 2, but 3 races. We will race in Germany at Formula Future, a completely new Formula Student race that focuses on sustainable energy sources. Then we will drive on perhaps the most iconic location, the Red Bull Ring in Austria. And finally, we will close our racing season with the race in France.
Today, we will present our car to you. As you might remember from the beginning of this presentation, we wanted our car to be competitive,
Reliable and powerful. And who better to explain it than the engineers who built it themselves? First, Rutger and Teun will tell you about the electrical and hydrogen system in our car, after which Philip and Nienke will show you the mechanical innovations made this year. So let's welcome to the stage Rutger and Teun.
Thank you, Ramon, for the introduction. So my name is Rutger, and this year I had the honor to be chief of the hydroelectric department.
And my name is Teun, and I'm this year's hydrogen and cooling system engineer. And today we'll take you along the 4 main topics of our hydrogen system and how we improved it. So, our racing car runs on gaseous hydrogen, where in a chemical reaction, oxygen and hydrogen react to create water, electrical energy, and heat. This all happens in our fuel cell.
So the hydrogen powers our car, and water creates beautiful mist dams at our exhaust. But you might wonder, how much hydrogen do we actually need to drive a race?
We have calculated to need about 800 grams of hydrogen to race 22 kilometers on full throttle. So, after a lot, and I mean a lot of discussions, meetings, visits, and many more, we can finally say that we have managed to acquire a tank of a whopping 1,000 grams of hydrogen, over tripling our capacity. This tank holds hydrogen at a pressure of 350 bars. This is the same pressure you would experience at the bottom of the Atlantic Ocean. But fear not, our tank can withstand at least twice this pressure. With this tank, we have now a higher hydrogen capacity as well as a higher hydrogen flow.
More hydrogen flow indeed. Now, you would think we also need larger tubes to handle this higher flow rate.
We thought so as well, but we were wrong. Thanks to all the testing data from previous year races and the resulting testing table that we built this year, we could make the calculated conclusion to need smaller tubes instead of larger tubes, saving both weight and materials. And that's not the only part where we save tubing. As I previously mentioned, we also need oxygen, which we get from the air around us. We mainly focused on the path this air must take. By combining 2 previously industrially available components into one custom-built component, we have significantly reduced the path the air has to follow. This benefits the overall performance of our car.
So we have hydrogen and oxygen. The balance and state of these 2 gases is crucial to maximize efficiency. It can be quite difficult to know beforehand how the system is going to react to such changes that we make. That is why this year we have built a digital model of our car, which we can use to simulate design choices and see if they will be an improvement or not. This way we can play around with the system without taking everything apart or organizing an entire test day, which saves a lot of time and resources.
So you talk about balance and states in a model. But in a race, how do you know how the system is behaving?
That's where our fuel cell control unit comes in. This is a circuit board which you can see as the brains of our hydrogen system, and it is designed and programmed in-house by our team. We are the only team competing in Formula Student that has a fuel cell control unit. It constantly monitors the state of the system and sends signals to make sure that everything is running smoothly. And we have many more circuit boards on our car, more than 20 in total, and all these circuit boards need to be connected to each other.
Damn, that is a lot of cables.
It really is, though this year we've taken a completely new approach to routing these cables. Using sophisticated software, we could load in all of our electrical connections in a 3D model of our car. Now we know exactly where each cable and connector has to go before we even start assembly.
And from this 3D model, we could finally make our wire harness. By designing before building, we can massively reduce the amount of cables needed in our car. Furthermore, we can also better work around some thicker cables, which might be hard to bend.
Now we need those thicker cables to transmit the high power to the electric motors from both the hydrogen system and the battery pack.
Battery pack? I thought we were running on hydrogen.
Well, yes, we are running on hydrogen. The thing about our hydrogen system, though, is that it cannot scale up its power output as quickly as the driver would want during a race. Just like a hungover student, there may be a little bit of delay in its output.
Think of it like this. Our fuel cell can supply a constant amount of power. However, when we want to accelerate, we might exceed this power. Therefore, we have a battery to act as a buffer. Then, when we start to drive more constant or decelerate, we can recharge our battery again for when we want to accelerate. This way, we can play around with the power output of our car.
Now, with such a battery, you would of course not want to put in more energy than it can handle, nor do you want to try and take more energy out of it than it contains. To make sure this does not happen, our team has designed and implemented a new battery management system.
Our embedded team has been working tireless nights to design and create a both software and hardware-wise custom-built system which ensures our battery charges evenly and we are never in the dark on the battery level of our batteries.
And that's not the only improvement we made to the battery system. We used to have 2 battery containers taking up all the space in both of our side pods. This year, we reduced the volume of our battery pack by 50%, freeing up an entire side pod. Now we have the same amount of energy and only half the amount of space, and by doing so, we lost over 10 kilograms of weight.
This means that we have some free space in the other side pod, where our second battery container used to be. We use this additional space to put our new and larger hydrogen tank in there. We have talked a lot about more energy and higher power densities. But what are we going to do with it?
Well, this year, we're going to drive faster than we've ever done before.
This higher power means that both our motors and our fuel cell will produce more heat, which we need to cool. Did you know that we use 2 separate cooling loops? This is because our motors and our fuel cell work best at different temperatures. And this difference in temperature sparked an idea for an ingenious new radiator design.
So our cooling loops are air-cooled, which means that we need a lot of air passing through our radiators. This year we came up with a serial radiator design, placing 2 radiators behind each other.
Yes, so to achieve this fast amount of cooling, we really need a lot of air. However, where are we going to put this? As a wise man once said, building a racing car is a competition of compromises. And how that puzzle has been solved is absolutely out of my scope. For that, I would like to invite our mechanical engineers, Philip and Nienke, to the stage, who will tell you how they managed to fulfill all of the flashy new wishes that we delivered to them. So please, a welcoming applause for our engineers.
Thank you so much for the introduction, Teun. I'm Philip, this year's Chief Mechanics. As such, I had the privilege of overseeing the mechanics department, the people responsible for using the power generated by hydroelectric. And I'm here with one of our engineers.
I'm Nienke, one of the vehicle dynamics engineers, and we're responsible for designing the suspension, the steering, and the braking systems.
Together, Nienke and I will take you through the 4 fundamental areas that make the mechanics of our car tick. And I'd suggest by starting off where Rutger and Teun left off, by building on what they've explained to us so far. As they mentioned, it's a huge win that we were able to increase our cooling capacity. But obviously, you need a significant amount of airflow through those radiators. That's not easy to manage, is it?
Not at all. To make sure the radiators get enough air, our aerodynamics sub-team came up with an ingenious design that moves air with an impressive efficiency to those radiators, despite the tight packaging constraints. And this is what makes a new cooling loop possible. And thanks to that, we increased our cooling capacity by 50%.
But aerodynamics isn't just about cooling. All components work together as a single system to make sure the air is guided exactly where we need it, especially through those radiators. We've also redesigned our front and rear wings.
Using extensive computer simulations, we're able to reduce drag and increase downforce. In fact, the wings at the front now produce 50% more downforce, while the drag at the rear has been reduced by 50%. That means we're gaining grip without sacrificing speed.
And we didn't just stop at design. We've also improved our production method. By 3D printing the wing molds and post-processing them, we were able to remove the rough, orange peel-like surface of the wings. As a result, real-life performance becomes much more similar to that of our computer simulations.
And all of these changes help the car grip better in corners and go faster on straights. And these improvements become more and more important as our top speed improves. And our drivetrain sub-team has played a major role in that improvement.
Exactly. Last year, we used an off-the-shelf gearbox that wasn't really made for a car like ours. We could only run it at 5,000 RPM instead of the 20,000 our electric motors can generate. So we pushed it to 8,000 as we always looked for the limits of our components, but still, a lot of potential went unused.
And that's where the gearbox becomes so important. Unlike your own manual car, a gearbox is not only used for changing gears, it's used for converting the low torque, high-speed output of the wheels into a usable force that pulls the wheels over the asphalt.
The tricky part, however, is that the motor and wheels are immensely close together. You couldn't just fit it in a big gearbox. So our engineers came up with the perfect solution to this exact kind of problem: a compact, stepped, planetary gearbox. But what's that exactly?
A planetary gearbox uses a central gear, called a sun gear, that drives several bigger gears, called planet gears, around it. These planet gears are then mounted on a carrier, which transmits the output. And this compact setup offers a powerful transmission in a tight space.
Thanks to this gearbox, we can finally unlock the full potential of our electric motors, more than doubling our top speed from 40 to 90 kilometers an hour. Now, you might be thinking, wait, I hit that on my way here, so what's the big deal about that?
Yeah, but did you build that car yourself?
Probably not. But that's not the only reason why this is so impressive. See, on the short, tight, twisty tracks of Formula Student, 90 kilometers an hour is more than sufficient to become competitive. The real challenge lies in staying fast through all of these tight corners. That's exactly where suspension comes in. It holds the wheels in place and it absorbs the bumps in the road, keeping the tires in contact with the track. But in order to achieve that, you need numerous amounts of different components, and I think Nienke can tell us a bit more about that.
As you can see, the rear wheel assembly consists of a lot of components. I won't explain them all, as we'd be here all day, but the part that brings everything together is the rear knuckle. It's one of the most complex components we've designed this year, and it combines several suspension elements, the gearbox and the wheel, into one compact and strong structure.
This component is mounted to the chassis using 4 steel arms, and is damped at each wheel with a single spring. As Nienke mentioned, it's an immensely complex system, so we won't go into every detail, but maybe you remember a few months ago when Lewis Hamilton's Ferrari got disqualified because he had too much damage to his underfloor. Well, we thought of something to prevent that exact kind of issue for our own car.
We've developed a height adjustment system that sits on top of the damper. It consists out of 2 interlocking parts, and we can add thin shims between them. Adding more shims raises the damper, which slightly lifts the car off the ground. This means we can tune our ride height and get as close to the legal limit as possible.
Now, all of these components are immensely essential, but none of them really matter without the chassis. The chassis is the steel tubular frame that serves as the foundation of our car. What were the main improvements here, Nico?
We were actually able to shave off 15 kilos of just the chassis. We did that by optimizing all the tubes while still ensuring the safety of the driver.
And this becomes ever more important, because as the car gets faster, the forces it experiences also increase significantly during acceleration, braking, and, well, hopefully not crashing.
And with these increasing forces, the chassis and its components needed to be a lot stronger than last year. So that required more space, and with the redesign of many components, making them lighter and more compact, we had to rethink the entire layout of the car.
You can think of it like playing Tetris, but in 3D with very complex shapes and a lot of wiring and tubing in between. Apart from that, it's basically the same.
And on top of that, we also had to carefully consider weight distributions, as that directly affects how the car moves through corners.
So you may imagine that each component impacts each other. Changing one part often means reworking others, which can feel like a never-ending cycle. But I'm proud to say that I believe that we've managed that cycle pretty well.
And with that, I think it's time to show you what all these design changes have led to. And for that, I would like to reintroduce Maartje to the stage.
Wow. Our engineers really worked so very hard to make all of these improvements happen. And I hope you are just as proud of them as I am. And in case you are a bit overwhelmed by all the innovations we've just presented to you, let me summarize the biggest ones. We implemented a new and bigger hydrogen tank and went from 2 battery packs to 1. We upgraded our cooling system with a completely new radiator design, and we designed and implemented a completely new planetary gearbox. As you remember from the beginning of this presentation, we wanted our car to be competitive, reliable, and powerful. The last two, we have already achieved. And regarding the competitiveness of our car, we will prove that this summer. But for now, I won't keep you waiting any longer. It's time for the moment you've all been waiting for. So here she is, our car, Nova. We are incredibly proud to present her to you. The past few months have been a wild ride, full of challenge, hard work, and a whole lot of learning. And I am incredibly proud of every single member of our team for their dedication to our car, Nova. And because of that, I would like to take a moment to shine a light on all the people who worked so very hard to bring Nova to life. Starting with our embedded systems sub-team. Powertrain. Hydrogen system. Cooling system. Aerodynamics. Structural. Vehicle dynamics. Drivetrain. The chiefs. Marketing and communication. And management. But we didn't do it alone. I would like to thank our friends and families. It's because of your constant encouragement and belief in us that we were able to pour our energy into this project. We couldn't have done it without you. And I would like to give a special thanks to all our partner companies. Without your support, this project would not have been possible, and we would not be standing here today with Nova. We are incredibly proud of everything we have already built together, and even more excited about what lies ahead. And finally, I would like to thank the Wilming Theatre for their support in the creation of this event. To celebrate, we'd love for you all to join us for a drink in the foyer, where you can have a closer look at Nova, and we will happily answer all your questions and take you along in our excitement. Nova is not just a car. She's a symbol of what happens when teamwork, passion, and innovation collide. Thank you for believing in us. And now, let's drive the future together.